All right, we'll take a look at letter J. Here we go. Letter J, 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 J. Let's see, that doesn't look like my visualizer's right, but let's see what happens. There, it's fine. Okay, so sometimes we have absolutely no choice but to grab some kind of a graphing utility to come up with something. So notice it says, let's go ahead and use that graphing calculator. We should know what a cosine looks like. It's some kind of a graph that looks like that, right? Remember, they were an even function, and then we had the graph of, like, say, x squared, which, of course, is going to come like this. Now, pretty clearly, very rapidly, I can tell this sucker has two answers, and it's going to, but sometimes it might be harder to know. I also know that this is an even function. So as soon as they're both even functions, in fact. So as soon as I find one answer, I know the negative of that answer is going to be another valid one. So, right, let's just see what we got. I'm going to make sure my calculator's in radian mode. Calc, we're generally going to be in radians. We've got the cosine of x, and we've got x squared. And just based on what I know about this problem, you know that it's not going to be very far to the left or the right. And we know that the cosine only goes up and down between -1 and +1. So I'm not going to need a whole lot of space on this graph. So I'm just going to go ahead and let the values go, say, from -2 to +2, because that's actually more than enough space for this particular one. So let's see what we got. So here's my cosine wave. Here's my x squared wave. And of course, if I find my intersection, remember we go to second calc and number 5. We can pop over here, triple enter, and my two values are x equals 0.824. So x equals plus or minus 0.824. And I'm going to go ahead and hold on just a second, everybody. I'm going to hit pause. Yeah, sorry, I had a little visitor for a second here. So back at it. So let's see, share, please share, please share. Okay, there we are. Okay, so we found that first one, and then this other one is a little obnoxious. I really don't know exactly what this answer is going to be right off the top of my head, but I know that exponential graphs have kind of this flavor and logs kind of have this flavor, but they may not cross, or maybe this one goes up a little bit higher and maybe crosses a couple of times. I'm not totally sure. But one thing I do know for sure is that the domain of this one, although it's going to be over here somewhere. Anyway, it's not going to be really negative or anything. Remember, you can only take the log of positive numbers. So the domain of this one is going to have x is going to have to be larger than -2 at least, because otherwise that would be 0. But I usually try to stop and think a little teeny bit about what I'm going to do before I start throwing stuff in, so I can think of an appropriate window before I just start typing. So anything bigger than -2 is probably going to do. I don't really know how much to give it, but this one, remember, this range, it only gives me positive numbers, so I don't need to go down very much, but it does go up very, very high. So I'm just going to go ahead and hit graph and see what happens. So there's my exponential graph. Here comes my logarithmic graph. And so let's go ahead and find those two intersections. Remember, we do second calc, number 5. There we are. I had to find my cursor, hit enter 3 times. Just a sec here. X equals 0.503. Or x equals, let's see, our other point of intersection is over here to the left. Let's see, let's move a little bit close. Remember, 3 enters. And we're looking at 1.665. Negative. Should be negative 1.665. No, see very well. Now, the bottom part of this particular handout is really not anything where I'm specifically asking you to do something. It's just be aware of it. Remember that absolute value functions are functions that look like everything is positive on one and negative on the other. Remember, they're a piecewise defined function. You want to remember that odd functions have origin symmetry, so they spin, and that means something like f of -4 is the opposite of f of +4, things like that. Even functions are ones where if you plug in -6 or +6, you get that same thing. So they have beautiful y-axis symmetry. So knowing the right side and the left side match. And also knowing that there are issues when you graph things where sometimes neither endpoint is included, where both of them is included, or one of both, right? Partially included, partially not. Distance formula, last thing, just remember, last year I actually didn't do it this way. I told you to think about it as delta x squared and delta y squared. Remember, because that's like a rise over run. We would talk about this as a slope triangle, right? And use the Pythagorean theorem to solve that. So that's a quick little look at letters J and the end. So hey, hopefully that was helpful, and I'll see you guys back in class. Bye-bye.